This video is graphs and transformations of exponential and logarithm functions. Most of this is going to be review, if not all of it, and remember that you can use either a TI-84 calculator or you can use the Desmos calculator as well. So our learning target is I can graph and transform functions. Okay, so at the very beginning of the year, we looked at transformation rules, and this is also things you have seen in Math 1, Math 2, and Math 3, if you remember it or not. So anytime you have something like this, that's when you shift left. This will be a shift right. When you add something at the very end, it shifts up. When you subtract something at the very end, it shifts down. If you have a negative in front of the entire equation, it's going to reflect over the x-axis. If you have a negative like inside a set of parentheses or wherever the x is located, it's going to flip it over the y-axis. And then you can either have vertical compressions or stretches, and you can have horizontal stretches and compressions. So if this doesn't seem familiar, you can go back and re-watch those videos on transformations if you need to. Okay, so the first thing we're going to do is we're going to A, identify the parent function, and B, describe the transformation. So the parent function, remember, that's what it is like before you did anything to it. So usually I say like you would just take all the numbers away. However, because this is an exponential, you definitely need to keep the base and the actual exponent. Alright, so this would be my parent function. Alright, so part B, I'm going to describe the transformations. So the transformations occur where extra stuff has been added to the parent function. So the +1 in the exponent has done something, and the -3 at the very end has done something, and now we just need to figure out what did it actually do. Okay, so what I'm going to do is I'm going to graph the parent function and the ending function in Desmos really quick, and I suggest you do it with me. So let's pause the video and try and graph them in 1, 2, 3. Okay, so hopefully that was enough time. So the one in blue is your parent function, and the one in red is your ending function. And you can see, if you're looking from blue to red, that it definitely moved down, and it also looks like it moved to the left. So if you're going to think about that blue one moving down, let me see if I can draw it. So if it just moved down, it would look like this, but then it also looks like it moved over to the left. So let's get back to that original equation, and you can look back at that rule. Okay, so when anything has been added or subtracted to the x, it's going to move it to the left or right. So because you have a +1, this is the one that looks like this. So because something has been added to the x, that means it's going to shift left, and it's going to shift left 1 unit. The +3 at the very end, that's this rule, that is a shift, oh sorry, this is a minus. That would be a shift down, so this would shift down 3 units. So once again, you can see transformations by just graphing them. Sometimes it's a little hard if you're not great at visualizing, or you can just use the rules. And these are the rules I'm referring to. So going back and looking at these rules. Okay, so we're going to do the same thing with this one. A, we're going to identify the parent function, so what was the original, and then B, we're going to describe the transformation. Okay, so the parent function, okay, I don't really need that 4/3 there. It's not like a base of an exponent or anything. So my original would be this. So just a base E, because remember base E is a number. So that means that the 4/3 has done something, the negative in front of the x has done something, and the +5 has done something. So when we do part B, we have to list what each of those parts did. And you can look back at the rules, and you can also graph them if you need to. Okay, so here are the rules you're actually looking at. So because there was a number added to the very beginning of the function, that 4/3, that's how I get this rule. So this means there was a vertical stretch of 4/3. All right. The next part, with the negative in front of the x, that's this rule because there's a negative in front of the x. I mean, that's exactly what it is. And that rule says that when that happens, there is a reflect across the y-axis. And then the last one, so something has been added to the very end of the function, and when that happens, that would be a shift up, and it would shift up 5 units. You can graph that in Desmos and see if it looks like that happened, but just trusting the rules, I'm just going to move on. Okay. All right, so we're going to do the same thing with this one. So for part A, we're going to identify the parent function. Okay, so usually I say just drop all the numbers. However, you do have to have that log base 3. So this would have been your original. And if that is your original, then I'm just going to circle all the extra stuff. So you got a -1 beside the x, and you have the +2 at the very end of the function. So I want you to look at the rules and see which 2 you're actually using for those. So pause the video and see if you can do that in 1, 2, 3. Okay, so here's the 2 rules that were actually used. I chose the first one because notice that something has been subtracted from the x inside the parentheses. So when that happens, that would be a shift to the right 1 unit, and then the +2 at the very end. So you had your original function, and then you added something at the very end. That's why you're using that rule. And when that happens, that would be a shift up 2 units. So then you could graph both of those, and you could just look and see if it actually makes sense. Sorry. So to save time, we're just going to keep moving on. All right. So same thing. We're going to identify the parent function. All right, so we definitely need to keep the base of the log. And then anything else is what has been transformed. So this negative has done something. This +5 has done something. I want you to pause the video and see if you can figure out what rules have been used, or you could graph and just try to list out the transformations. So try that in 1, 2, 3. Okay, so notice that there's a negative in front of the entire equation, so that's why I use this rule. And when that happens, that is a reflection over the x-axis. And you can graph it just to check that that actually makes sense. And then there has been something added to the x inside the parentheses. That's why I chose that rule. And when that happens, that is a shift left. And because you added 5, shift left 5 units. Okay. So now let's just go back over some key features and doing all that fun stuff. And I say fun in a sarcastic way. Alright, the first thing I want you to do is either using your calculator or a Desmos calculator, I want you to sketch a graph. Sketch it as accurate as you can. So try that in 1, 2, 3. Okay, so don't make fun of my artistic abilities. It should look better than what I just drew, but something similar to that. Okay, so remember, a domain is how far left and right you go. Because you do go left forever and right forever, this is a domain of -infinity to infinity. The range is a little bit different. So remember, range is from bottom to top. The lowest it ever gets to is -4. And then the highest it goes is to infinity. And then I would put this both in parentheses, because I don't know if it actually touches -4. I would assume that there's an asymptote at -4. Okay, so then you can find the, well, let's just say y-intercept, my bad. The y-intercept is at 0. I'm going to put this in fraction form, negative 11 thirds. Okay, because you have this shift down, that's why I know that there's an asymptote at y equals negative 4. So there's like an invisible line right through here that the graph gets really close to, but it actually never touches. So whatever the number is at the end, that's where your asymptote is. And once again, that's from Math 3 stuff. Okay. It is increasing. Remember, you read graphs from left to right, so this graph is going uphill forever, so negative infinity to infinity. It does not decrease. And then we need to talk about in behavior. So remember, in behavior means what's the left side doing, what's the right side doing. So the right is definitely going up, up, up forever, and the left is actually just going towards negative 4. It never goes below negative 4, but it just gets really, really close to it. So here's the weird part. This is how you write it. If I want to say the left side of the graph, I say as x approaches negative infinity. Remember, that just means left. F of x, we said, is going to negative 4. So f of x goes to negative 4. If I want to say the right side of the graph, I say as x approaches positive infinity. And we said the graph goes up forever, so it goes to positive infinity. So remember, this is just fancy notation for saying the left side goes to negative 4, the right side goes up forever. And you just have to get used to using the notation and being able to read it. Okay, so take just a couple seconds, graph this, and sketch a graph. Do that in 1, 2, 3. Okay, so something like this, and then we'll do the key features. So the domain keeps going left and right forever, so negative infinity to infinity. The range, it's going to get really close to negative 1, but it never actually touches it. So I'm going to say it starts with negative 1, and then it does continue to go up forever. The y-intercept, I'm going to round to 2 decimal places. Can't put that one as a fraction. The asymptote, remember, anytime there's a shift up or down, that's where your asymptote is. So my asymptote would be at y equals negative 1. So that means that there's an invisible line right here. The graph gets really close to it, it just doesn't touch it. This one is always increasing, which means it's never decreasing. And then we'll do in behavior. So remember, in behavior is just left side and right side. The left side is just getting really close to negative 1, and then the right side is going up forever. So in notation form, the way we write that is left side means as x approaches negative infinity, the graph goes to negative 1. So f of x goes to negative 1. If I want to say the right side of the graph, I say as x approaches positive infinity, and if I want to say the graph goes up forever, I would say f of x approaches infinity. Alright, so let's do a natural log. So go ahead and pause the video and graph it. If you want to try doing the key characteristics, you can. And if you get stuck, you can always play the video. Just try something in 1, 2, 3. Alright, so this sketch is a little different. Sometimes the graph is a little misleading. So it should look something similar to this. So when we say domain, it definitely doesn't keep going left forever. It's kind of stopping at 0. So it gets close to 0, but it does continue to go right forever. So I'm going to say from 0 to infinity. It does go down forever, and it's going to go up forever, just very slowly. So negative infinity to infinity. The y-intercept, I'm not going to worry about that, because you kind of can't really tell. It's just kind of getting really close to the y-axis. So really, there is none. And the asymptote, I'd say, is at x equals 0 this time. So there's kind of like an invisible line going right through here. And that's why the graph is going to get really close to it, but it never actually touches it. This graph is always increasing, never decreasing. The left side over here is definitely going down forever. And then the right side, it's actually going up, but it just goes super slow. So the way we write that As x goes to negative infinity, the left side of the graph goes towards negative infinity, so it goes down forever. As x goes to positive infinity, the right side of the graph goes up forever, so it goes to positive infinity. Okay, so that's just kind of reviewing what graphs look like, what key characteristics look like, and what transformations. So stuff we did in those first units at the beginning of the year. All right, so you see if you have any questions, let me know, turn your notes in, get you some good grades, and I'll see you later. Bye.